So it's been a few days since I plated the probiotic. I did the dilution series and I plated it onto agar plate, and I'm going to go through to see what the growth is like and then choose the plate that has a reasonable number of colonies, so of the probiotic cells to count, so not too many and not too little. Ideally, I want to be able to count between 20 and 200 colonies or cell, or 30 and 300. So this was the most diluted one, the first one, the 10 to the 1, and if you can see, but you can't see individual cells, it's just a smear. So this is too many to count. And I did 3, still too many to count, still too many to count. This is 10 to the 2, so that is like 100, or 0.001. 10 to the 3, usually you'd start seeing separation of the cells, but as you can see, it is still a smear. Ten to the 4, so think 0.0001, still a smear. Still can't see individual colonies. And then I done 10 to the 5, or 10 to the -5. A little separation, but it's still too concentrated, too thick. So I noticed that all of them, even though the most diluted plate had a lot of colony that I wouldn't be able to count, so I decided to redo it and do a longer dilution spread. So I went to 10 to the -12. So I'm going to look at those plates. Right? So the 10 to the 1 for the other one that I did grew differently compared to the 10 to the 1 here. It's the same thing that I did. Actually, I made it more diluted. So I realized that when I did this one, the original, I had too many cells in it. So I diluted it a bit in more liquid so I could get it to grow spaced out or into individual colonies. So this is a 10 to the 1, still too much to count. 10 to the 2, still too much to count. 10 to the 3, still too much to count on both of them. 10 to the 4 on this one, I can start seeing individual colonies. So those are the yellowish creamish dots, still too much to count. And I get to the 5, that's a bit countable, still a lot. So this is 10 to the 6. I can count these, so I'm going to put 10 to the 6 aside to count it. 10 to the 7, you see it has gotten less, and that's what you want as you move down. So this is 10 to the -7, still less. This is 10 to the -8. I can count these two, so maybe I would count that. By the time I get to 10 to the -9, there's hardly any on it. I think just 1. 10 to the 10, maybe the hockey stick was too hot, so it killed some of them, because 10 to the 9 should have more than 10 to the 10. So enough to count. I gauged the agar here, so that's why it is in a clump. And the 2 lowest or most dilute, so 10 to the -11 and 10 to the -12, the plates are clean, so there are no colonies on it. Now I'm going to walk you through how I'm going to count, enumerate, see how many colonies of cells are in my probiotic. Is there really 5 billion? So I have decided I'm going to use the 10 to the -8 plate as the plate that I'll count. So I identify the plate with a countable number, typically, as I said, between 30 to 300, right? I like that it's more spaced out. And once I've identified the plate, so the dilution factor, I said I was going to select the 10 to the 8 or the 10 to the -8, right? And so this is the plate that I'm going to use. How many or how much, what volume of the probiotic I added onto the plate. So I added 100 microliter or 0.1 ml. Okay, I'm going to calculate if my actual probiotic contains 5 billion cells, as the bottle says it did. So what you need to do, or what I'm going to do, as I said before, I'm going to choose the 10 to the 8 plate, right? Because it has countable cells. You want ideally between 30 to 300 to be able to count that. And so that represents my dilution factor, right? I'm going to do 10 to the 8. So that's the plate I'm going to count. And N represents the number of colonies that I'll count there, and the volume plated. So the volume of this, the 10 to the 8 dilution of probiotic that I plated here was 100 microliters or 0.1 ml. So the formula for counting the colonies, which is CFU, which stands for colony forming unit. Each of these cells represent a colony forming unit per ml, so per volume, milliliters, equals the number of colony, right, N, that I'm going to count on this, times the dilution factor. Remember I said the dilution factor was the 10 to the 8 dilution that I plated, and it's going to be divided over the volume of the probiotic plated, which would be the 0.1 milliliters. So in grad school, this is how I counted my colonies. If the plate was bigger, or some people, you could draw a grid. So divide your plate into a quadrant, so 4 down the middle horizontally and vertically, and then maybe count how many are in one grid, then times that by 4. But for this, because the plate is, I didn't use a large plate and it's small enough, I am going to go ahead and just count individual colonies. And I have some rules. So if I see 2 of them come together, I will not count those, or you can decide to just count it as one. The reason you want to avoid counting compounds or count it as one is because when it's clump, you don't know how many of the cells are there, right? A big clump doesn't mean that you have 2 cells. It could be 10 cells in that little clump. So you can avoid counting it or counting it as one. So let the counting begin. So I just take my marker and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Sixteen, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I counted 225 colonies, right? So let us do the math now. So I counted 225 cells or colonies on the plate. So this represents N, the dilution factor, that's how many times it was diluted, because I chose the 10 to the 8th plate. So this is the dilution factor, 10 to the 8th. And the volume plated was 0.1 ml or 100 microliters. So because the formula is colony forming units, so CFU, colony forming units per ml, you can also do per gram, but I'm going to do per ml, equals N, the number of colonies or cells counted, times the dilution factor, which is 10 to the 8th. You could also do 1 over 10, right? Times the volume plated, and because it's in ml, so I'm going to do 0.1 ml. I'll put that into my calculator to find out how many cells are in my probiotic, if it's actually 5 billion. So N, as I said, was 225 cells times 10 to the 8th. Dilution factor times volume plated, 0.1 ml, equals, so 225 times 10 to the 8th times 0.1 equals, okay, I'm going to put this in scientific notification, 2.25 times 10 to the 9 CFU per ml. Okay, so according to my probiotic bottle, now says that there were 5 billion CFU, coliforming units or cells. And I calculated based on my experiment that I had 225 billion. So it's good to know that, I mean, you actually have more than what they say is on the bottle. And I would hypothesize, make an educated guess, that the reason I put 5 billion, because it's so difficult to ensure that whatever number you start with, like when they're making it, that's the number I would get or the customer would get. They would go and put way more. So even if a bunch of the cells die off, by the time it gets to you, there will still be an adequate amount to provide the beneficial effects that the customer bought this probiotic for. So, okay, now, good job. It actually has 5 billion cells, so that is good. So many yeast cells. It's so hard to see their shape. There are so many yeast cells. Look at that. And it's very diluted.